Welcome and good day to all of you. In this video session, we are going to see about high performance liquid chromatography. Hplc is an acronym for high performance liquid chromatography or high pressure liquid chromatography. It is an analytical technique used to separate, identify or quantify components in a mixture. The mixture of sample is separated using the principle of column chromatography and then identified and quantified by spectroscopy. Hplc is thus basically a highly improved form of column liquid chromatography. The principle behind this technique is the purification takes place in a separation column between a stationary and a mobile phase. The stationary phase is a granular material with very small porous particles in a separation column. The mobile phase is a solvent mixture which is forced at high pressure through the separation column. In a small tubes or a capillary made of stainless steel, the sample is injected using a syringe. The individual components of the sample migrate through the column at different rates because they are retained to a varying degree by interactions with the stationary phase. The individual substances are detected by a suitable detector and passed on as a signal to the Hplc software on the computer. A chromatogram in the Hplc software allows the identification and quantification of the different substances. The basic components of an Hplc system are shown in figure. The columns that are used in Hplc are made up of very homogeneous small particles which show improved physical and chemical stability, faster separation and better reproducibility compared to the traditional columns having soft gels. Very small, tightly packed particles offer a high resistance to the mobile phase flow, and the mobile phase therefore needs to be pushed through the column at a very high pressure. Pumping system is said to be the heart of Hplc. The role of the pumps is to force the liquids into the column at desired flow rates, usually between 0.5 to 2 ml per minute. Pumps in modern instruments can reach pressures in the range of 6000 to 9000 psi. The pumps can be used for delivering either a constant or changing composition of the mobile phase. The next important part is injector. It is used for introducing the sample into the mobile phase flow stream just before the column. It is connected with a loop that determines the maximum volume of the sample that can be injected. The samples are injected using a syringe, and the sample can also be introduced into the system using an automatic injector called an auto sampler. The next is column description. The separation is performed inside the column. The reason columns are often prepared in a stainless steel housing, since stainless steel is tolerant towards a large variety of solvents instead of glass columns. The packing material generally used is silica or polymer gels compared to calcium carbonate. The column is made up of small particles with very high homogeneity. Small particles provide more surface area and higher resolution. As the particle size decreases, the pressure required for achieving optimum mobile phase flow increases. Usually, the straight columns of between 20 to 50 cm in length are generally used. Short columns are required for liquid adsorbent and liquid-liquid chromatography, whereas for other modes, longer columns are necessary. The internal diameter of the column is usually 1 to 4 mm. The columns usually possesses an internal mirror finish which allows efficient packing. The packing material is supported by a porous stainless steel or Teflon plug at the end of the column. There are three forms of column packing material available based on the rigid solid. The first is microporous supports, where microporous ramify through the particles. These particles are generally 5 to 10 mm in diameter. And the second one is pellicular supports, which consist of a solid inert core onto which are coated several porous particles. These supports are therefore superficially porous. The third packing material is bounded phase, where the stationary phase is chemically bonded to an inert support. The procedure for column packing is as follows. Packing has to be uniform without any cracks or channels for obtaining optimum separation. Rigid solids and hard gels should be packed as densely as possible. Care should be taken not to fracture the particles. Usually, high pressure slurry technique is used for packing the column. A dense suspension of the packing material is prepared in a suitable solvent. The column is sealed with a porous plug at the bottom. The slurry is now pumped into the column at high pressure. The column so packed is then equilibrated for a long time by passing the developing solvent through it. Nowadays, pre-packed columns are available in the market. The next part is the detector. A detector allows monitoring the chromatographic run in real time. It is imperative that the sensitivity of the detector is sufficiently high and stable. UV visible photometers can be used for HPLC. These detectors are inexpensive and sensitive, but they are insensitive to normal flow and temperature fluctuations and well suited for gradient elution. So, lipids, carbohydrates, fatty acids, hydrocarbons, etc. are undetectable by these detectors. UV visible spectrophotometers with wavelength selection range of 200 to 800 nanometer are very popular for HPLC detectors. This slide shows you the solvents and the absorbents used in the HPLC. The HPLC has developed into a universally applicable method so that it finds its use in almost all areas of chemistry, biochemistry and pharmacy for analysis of drugs, synthetic polymers, pollutants in environmental analytics, determination of drugs in biological matrices, isolation of valuable products and water purification. Below is the advantage of using HPLC. Speed, efficiency, accuracy, versatile and extremely precise when it comes to identifying and quantifying chemical components. Hope in this video you learnt about HPLC. Thank you for watching. Have a good day.